Welcome to Meany Hall. Please take a moment to silence all cell phones and electronic devices. The use of cameras and recording devices is not permitted. Thank you.
Good evening, and welcome to tonight's public lecture with Neil deGrasse Tyson. I'm Jerry Baldesty. I'm the Vice Provost and Dean of the Graduate School here at the University of Washington. This evening's lecture is a special occasion for us because it marks the end of the 40th anniversary celebration of the Graduate Opportunities Minority Achievement Program at the University of Washington. 40 years ago, a group of dedicated and truly brave people began the premise that we need to do a great deal more to diversify graduate and professional students at the University of Washington, to bring more people into this great university, and then to turn them loose out in the public. They really believed the mission of a public university was to educate everybody in the state of Washington and in the region. This has been a year-long celebration, and we've heard from a series of important scholars. They've shared their research on things such as Mexican migration and demographic changes. We've had a conversation about the value of diverse voices in the arts. And tonight, we'll learn about one man's journey into the galaxies and beyond. All of our speakers have been inspirational and have challenged us to think about what we can do to make a better future for all of us. This is our 40th anniversary year for the Graduate Opportunities Minority Achievement Program, and I want to acknowledge the work of this office in the graduate school, and especially the work of Associate Dean Juan Guerra, who has led for 5 years our efforts and our goals to recruit and retain the very best among our students. GOMAP supports important outreach programs, such as hosting tonight's special guests, future UW scientists, Seattle's very own Cleveland High School students. Where are you? Stand up, stand up, stand up. They're the Eagles, right? Study hard. Call me in about 5 years. We also have students here from Franklin High School, the Quakers. Where is... Yeah, okay, yeah. I would like to acknowledge the two generous endowments that made this evening's events possible. Established in 1961 and 1990, respectively, the Jesse and John Dans and the Mary Ann and John Mangles endowments allow the University of Washington to share many talented scholars with our community. And finally, I wish to express sincere thanks to all of you who have joined us here tonight, both here in Meany Hall and those of you online at uwtv.org. Dr. Tyson will take questions after his talk, and you can text him at 25827, 25827. To ensure that we get it right, please begin your question with the word UW grad. Again, that's 25827, UW grad. Our speaker tonight, Neil deGrasse Tyson, will be introduced by UW astronomy graduate student Aoma Shields.
Good evening, and thank you, Jerry. As the dean said, my name is Aoma Shields, and I am a second-year doctoral student in the astronomy department and the astrobiology program here at the University of Washington. I'm grateful to the Graduate Opportunities and Minority Achievement Program and to the Graduate School for the honor of introducing tonight's speaker. 3 years ago, I emailed a NASA administrator who I didn't even know and asked her for guidance. I'd had a taste of science TV show hosting and wanted more of it. She wrote back promptly, "You should meet my friend Neil deGrasse Tyson. I'll introduce you. And by the way, he loves the movie Happy Feet. So you can't go wrong mentioning that." Dr. Tyson told me that a career in astronomy, be it research or science television, was self-limiting without a PhD. For his guidance and encouragement, I am forever grateful. Neil deGrasse Tyson was born and raised in New York City and graduated from the Bronx High School of Science. He earned his BA in physics from Harvard and his PhD in astrophysics from Columbia. Dr. Tyson has served on presidentially appointed commissions and NASA's Advisory Council to study the future and development of the U.S. space program. Among Tyson's 9 books is his memoir, "The Sky is Not the Limit: Adventures of an Urban Astrophysicist," and Origins, 14 Billion Years of Cosmic Evolution, which was made into a 4-part miniseries that Tyson hosted. Tyson is currently on-camera host of PBS Nova's spin-off program, Nova Science Now. Tyson's latest 2 books are Death by Black Hole and Other Cosmic Quandaries, which was a New York Times bestseller, and The Pluto Files, The Rise and Fall of America's Favorite Planet. Tyson is the recipient of 9 honorary doctorates and the NASA Distinguished Public Service Medal. The International Astronomical Union celebrated his contributions to the public appreciation of the cosmos in their official naming of asteroid 13123 Tyson. Tyson is the first occupant of the Frederick P. Rose Directorship of the Hayden Planetarium. Please join me in welcoming Dr. Neil deGrasse Tyson.
Good evening. Thanks for that warm welcome. Normally you save that for the end so that I earn it, okay? I just want to earn that from you. The sun came out today. I thought that was kind of interesting. In fact, I might tweet that right now, if I may. So let's go ahead and do that. Okay? So I have a tweet ready to go there. Let's see. In Seattle now, the sun came out today and people reacted joyously. Must be a rare event. Okay. 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 So we'll check back in on that later, why don't we? And let's get back to, am I there? Now, what I'm really going to do, this is really a talk on the musings of an astrophysicist. That's really what's going on here. This lecture might not even be coherent, because I'm just spilling out perspectives on things, just scattering them into the wind for you to receive, okay? So there's a little bit of everything tonight. I hope you don't mind. Now, often talks like this are just sort of loosely veiled commercials for some book somebody's going to sell. But this was no exception to that. No, actually, no, I don't like giving book talks because you can just read the book. If I'm there in person, I might as well talk about something you can't get from a book. So some of what I'll be talking about is in books, but the collection of it all together, you're not getting anywhere except here and now. So let's just start. So we're going to do some science up front, but then we're going to take you to new places, all right? In the search for life, what we're doing is we're trying to find the water. And we know there's water on Earth, and there's life everywhere on Earth where there's water. There's life. Even the Dead Sea. The fact that it's called the Dead Sea is an example of what you say when you don't have a microscope. Okay, so this is just how that was. Mars, there are microbes doing just fine in the Dead Sea. Mars, Europa, one of the moons of Jupiter, exoplanets. So our search for life is driven by the search for water. Europa is one of the moons of Jupiter where we're pretty sure there's an ocean, a liquid ocean of water beneath a frozen surface. So one day I want to go ice fishing on Europa, cut a hole, check out, see what swims up to the camera lens. You know what I like about Europa? Suppose we do find life. Then what do you call it? Call it Europeans, you see? that's what else would you call it? Let's go to Mars. We've seen Mars before. There's a nice shot of Mars. Can people hear me up on the top? Up in the cheap seats up there? You guys okay? You're all up there? Okay. Mars. Mars is intriguing because it rotates once in about 24 hours. It's tipped on its axis, so it has seasons. It's got polar ice caps. It gets everybody excited, especially this fellow, looking quite tweedy there. Percival Lowell, a wealthy New Englander who was wealthy enough to just sort of build his own observatory, and he called it the Lowell Observatory, yeah. Put it in Arizona, and he really liked Mars, and he was pretty sure life was thriving on Mars. So he wrote several books. This was his first. And you look in these books, and you find diagrams like this. And he called these canals, which was a mistranslation of canales in Italian, which meant channels. But he was wealthy, but he didn't know Italian. And so he thought the people who thought they saw channels, he thought they meant canals. And if it's a canal, it means it's artificially made. So this is what he saw when he looked through his telescope that he made and put in his observatory. Now, we know that none of these canals are there, and there aren't these cities. He was imagining life forms were going extinct, and they would channel water from the poles into the cities, and it was catching them right at the end of their civilization. So this is not the first crazy thing he did. But anyway, in modern times, we actually go there. Yeah, so there we've got one of the rovers. We went there before the rovers. You might know that. We went there back in the 70s. They were called Vikings. One landed, one orbited. And the orbiter took this photo. That's a good one. Ooh, oh, ooh, ooh. Yeah, that's better music here. The face on Mars. Dun, 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 dun. So everybody got excited. Well, sorry, not everybody. Those people who were sure that life on Mars had a simian face, okay? I mean, think about it. Most life on Earth does not have a simian face. Most life on Earth doesn't have a face, all right? So life with which we have DNA in common. All life on Earth has DNA in common. Now you're going to go to another planet and it has a face. The only things on Earth that have faces are like vertebrates have faces. That's a vertebrate face. So you want to say that there are vertebrates on Mars and they're simian in their biology. Well, there's only one thing that looks like a face, no matter the camera angle. And what is that? A face, yes. So we go back at another time, and this is what it is at another time with higher resolution. It looks less like a face. You can kind of see how it might have been. Now, all the Mars fanatics said, oh, the Martians figured out we were looking at them, and they quickly covered up the monument. Then you go back again, and it's like even less like a face. So the Martians have continued to cover this up, apparently. So more on that later. But in fact, I do have the first evidence from the rovers. This photo, in fact, has been kept from the public till I have special connections to NASA, as you heard in the introduction. So this one was the first image taken by the rovers, and it's been suppressed by NASA ever since. Right. So I thought I'd share it with you guys because, like, you know, you're my people tonight here. By the way, if you're looking on Mars for faces, why not look for other things that are familiar? You know, you only see that as a face because we have a face. And familiar things are what you pick out, even if they're not really there, right? When you look up in the clouds, you don't say, oh, I see a lobster. No. Has anyone ever said they see a lobster? No, you say, I see Abe Lincoln or George Washington. You're looking at sort of familiar iconography of our culture. And so let's find some more familiar iconography in the Martian terrain. There's the Valentine crater. There you go. We got one of those. How about the smiley face crater, right? So if you look hard enough, you can find stuff and call it whatever you want. So, but Mars, one thing is certain. It's long suspected, but recently confirmed, that water, while not on the Martian surface, is beneath the surface and not very far beneath. This is a crater about the size of this stage that was freshly left in the photo on the left side of the image here. And if there's water beneath the surface and an impactor comes, and an asteroid hits, and it makes a crater, that crater's, like I said, about the size of this stage, it will lay bare any water that happened to be beneath the surface. That water would melt on impact and then instantly freeze, and then there you get it, right there. You see the frozen sort of surface area there. Now you might say, well, suppose that's just chalk or some white rock. Maybe it's not really water. Well, you come back a few weeks later and it's basically evaporated. The official word for that would be to sublime, if you're into accurate chemistry vernacular. And so the point here is the evidence that water is beneath the surface remains manifest in many ways. And here's one where you see rivulets and a flood puddle over to the side. I mean, this is just, they're meandering riverbeds and river deltas, all of the telltale signs of water carvings that you fly over when you cross the Midwest in a plane. You see that on Mars. So definitely water's there. So water's good because maybe there was once life, but also water gives you energy. Did you know that the orange tank of the space shuttle has two tanks within it, one twice as large as the other? The big one contains hydrogen, the little one contains oxygen. You bring them together, the exhaust of that tank is H2O, otherwise known as water. And that is the very simple chemical formula for what's going on at the bottom, at the business end of the space shuttle. Okay? Now, it's also going up from the two solid rocket boosters on the left, but the main tank is essentially non-polluting because its exhaust is steam. The other two tanks, that's a different story. Let's go to Europa. This is the surface of Europa. This looks a little weird, but if you take pictures of the ice flows in the northern Atlantic, whatever ice flows remain, and you see them freeze, break, and refreeze, it looks exactly like this. There are places where you see cracks had developed and froze over again, interfering with previous places where tracks had gone through. So it's a rather busy place. It's been suggested that if you go to Europa, you don't actually have to dig through the ice. It might be a kilometer thick. You don't have to dig through because any place the ice cracked, water seeps up and then freezes again. So if there are any fishes down there, maybe a fish came up and froze, so there's like a freezer ready for you to just have your barbecue right there. You just park your ship right near one of these ravines, and right in the middle, that would be freshly frozen material from way down below. So maybe you don't have to. Other things we're looking for are exoplanets. Gliese 581G is an exoplanet, one of hundreds and hundreds and hundreds. In fact, this morning, if you listen to the radio interview that I had, I recommended an app for your phone, your smartphone. And it's called Exoplanets. Go check it out. And it is up-to-the-minute listing of every exoplanet that's been discovered in the catalog. You can see the orbit, whether it is a Goldilocks planet or not. And Goldilocks, that's pretty simple. It means if you're too close, your water evaporates. Too close to the host star. Too far away, it freezes. You want to be just right, like Goldilocks. And I was always disturbed by the Goldilocks story because, you know, if you're the Bears and you come home and, like, there's Goldilocks, done ate your porridge, done sleeping in your bed, and I think the Bears would have just simply eaten her, you see? That would have been, so the lesson would have been much more profound. Bears, those bears would eat people, see? So that's what I'm thinking. So you can find the orb, so it's G right there at the bottom. And for that star, that G is in the Goldilocks zone of its host planet. So I just wanted to just sort of get all of that out of the way. Let's move on. Let's move on to Pluto. Yes, so I keep getting blamed for Pluto. It's because 10 years ago, 11 years ago now, we opened an exhibit in New York City where we grouped Pluto with other icy brethren in the outer solar system, and the nation's population of elementary school children got pissed off. So my words of wisdom to you, okay. No, that's mean. No, that's mean. I'm not that mean. All the time, I'm not that mean. It all started with this guy. We've seen him before. Where did we see him? He started the search for Planet X that led to the discovery of Pluto, because he was sure that the orbit of Neptune, which was not following Newton's laws of gravity, that there was some hidden, unseen, not hidden, but yet to be discovered planet in the outer solar system tugging on Neptune. He said, find it. Well, you look for where it's supposed to be, nobody found anything. So this fellow gets hired, Clyde Tombaugh. He's 21 years old, gets hired at the Lowell Observatory, and he does a systematic search for Planet X. And lo and behold, he finds Pluto, named by an 11-year-old girl in England, not by an American. Discovered by an American, named by a Brit. No American would have possibly called this object Pluto. Do you know why? Because at the time, there was a laxative called Pluto water. When nature won't, Pluto will. Relief for constipation. So no American is thinking, I'm going to name this new cosmic object after my bowels. That's not going to happen. So it got named in England. The problem is, with this discovery photo, Clyde Tombaugh used to joke. They said, how did you find Pluto after all those? So it was easy, because there was an arrow pointing straight to it. So, anyhow, this object, which is moving in these 4 frames against the background, is the first ever icy body discovered outside of Neptune. Actually, it's the second ever icy body discovered outside of Neptune, the first being Pluto. This is a new swath of real estate discovered with this image, and we name it after the fellow who proposed its existence, Gerard Kuiper. It's the Kuiper belt of icy bodies, a Kuiper belt of comets. The number of objects now known is in the thousands, all discovered in the last 20 years. And some of them have orbital properties that greatly resemble that of Pluto. The same orbital tilt, they look and smell like Pluto. So those have been collectively called Plutinos. That's kind of cute. So Pluto has brethren out there. And this is what we knew in the year 2000. Pluto and they look more alike than either they or Pluto look like any of the other 8 planets. And we figured, hey, it's time for Pluto to own up to its actual identity. Because when it was alone, you can't make a class of 1. That doesn't work in science. So we said, okay, Pluto, we'll grandfather you in. Okay, we'll call you a planet. We don't know what else to call you, okay? Now it's got family. The Kuiper Belt. There you have it. And I think Pluto's happier there, okay? Really? Do you know that our moon is 5 times the mass of Pluto? Any Pluto lovers out there who didn't know that? See, that's kind of sets it straight for you right there. And you know, if Pluto were where Earth is right now, its ice content would evaporate and it would grow a tail. No, that's just embarrassing. You can't have a tail and call yourself a planet. So Pluto's been reclassified. I would be happy to call it a comet, but that would have been that was just, people would have just cried. So it's called a dwarf planet now. And so it's small. So these are other sort of dwarf planets out there. Pluto is among them. Pluto has 3 moons. Charon was the big one, the quote, big one. Nix and Hydra. But it's not alone out there, and it's probably not even the biggest. Eris is probably a little bit bigger than Pluto. But this is Pluto's family, and like I said, I think it's happier there. And this is where I work. You all invited? Just come on in. Say you know me, and they'll still charge you $19. But notice how we have the sphere in which we contain the planetarium, and we have the large Jovian gas giant planets suspended from the ceiling. The terrestrials, Mercury, Venus, Earth, and Mars, the cable would be like as wide as they are, so we just mount them on the railing. Pluto is not among them. Pluto is somewhere else in the exhibit, and that's what got people pissed off. And that's what made a page 1 story in the New York Times on January 22nd, 2001. What else should have been filling that page 1 on that date in that year? Think about it. Bush got inaugurated. Bush, that's the first news day, the second news day after the first news day after the inauguration news day. You inaugurated on the 20th, that news goes into the 21st. This appeared in the 20th. You'd think the whole page would be filled with information about Washington and the change of power. But there it was. Pluto not a planet, only in New York. That's when the mail started coming in. I have a whole file, and it went on for 5 years. What's this one here? Dear scientist, what do you call Pluto if it's not a planet anymore? If you make it a planet again, all the science books will be right. Do people live on Pluto? If there are people who live there, then they won't exist. So the cause and effect of things are not quite. Why can't Pluto be a planet? If it's small, doesn't it mean it doesn't have to be a planet anymore? Some people like Pluto. If it doesn't exist, then they don't have a favorite planet. Please write back, but not in cursive because I can't read in cursive. I got a whole folder of these things. My favorite comic, however, was this. Look at those shoes he's wearing, those little near-Earth objects. You know, these should not be called near-Earth objects. That's an official phrase, NEOs. They should not be called near-Earth objects because this is what they are, okay? I think they just don't want to freak people out. Can I get a little more volume on the mic? Because I feel like it went down a little. Just like messing with the sound guy. Thank you. Thank you. I think that's a little better. This is what they actually are. Any object that's classified as an NEO has an orbit that crosses Earth's orbit, which means it will one day collide with Earth. It will collide with Earth. It's not just maybe. It will. It's just a matter of when. And Earth has, you ever been here? Yeah, Arizona is famous for its holes in the ground. This is one of them. This is Barringer Crater. I've been there. This thing it freaked me out when I first went as a kid. there was a road trip and went to the Grand Canyon and this. And for me, Grand Canyon was like, okay. You go to this, Grand Canyon was like, took 1 million years to make. This crater took a 60th of a second to make, all right? It can bury a 60-story building and it's nearly a mile across. Well preserved because it's in Arizona where it doesn't rain much. So stuff gets hit and can get hit multiple ways. This is an impact scar on Ganymede, one of Jupiter's moons, and here's multiple hits in a row, like it's like carpet bombing. Well, you can have an asteroid break up, typically a comet, break up from tidal forces. Then you have this whole stream of objects. Now, if they all just came straight in, you'd think they'd all just fall on top of each other and make the crater wider and wider. But the object it's hitting is also rotating. So each next piece hits slightly farther in the opposite direction of the rotation, and that's what happened here. So there's not a question about whether things get hit. And this would be a bad day on Earth right here. Artist illustration by Don Davis. And that's pretty big, though. That's even bigger than the one that took out the dinosaurs. That's bad. Another really bad one, yeah. Let's be a little more realistic. Here's one about the actual size that would have taken out the dinosaurs. The one that took out the dinosaurs is about the size of Mount Everest. And obviously you're dead if if you're standing where it hit. You're dead immediately, all right? But it killed all the dinosaurs. 70% of all species on Earth went extinct after this thing hit. So our first indication that local phenomena can create global consequences climactically was gleaned by the computer models that analyzed this. Insights from the heavens. I once showed this, and someone in the front row, not even the back row, the front row raised a hand and said, "Is that an actual photograph?" And I was ready to no, front row people should know better. It's the back row people. Front row asked that. I was ready to just give up. We'll just go home. Then I said, well, let me play with that a little. Yes, it is. The pterodactyl had a digital camera, and we pulled the chip out of it, and it still had the, where do you go with that? Man. We have an asteroid headed towards us. It's called Apophis, the Egyptian god of darkness and evil. Not named by accident, that. Discovered in 2004, December. You probably didn't know when it was discovered because it was discovered the same week of the Indonesian tsunami. So rightly, it was buried in the news cycle. However, the reason why this is important is the very first calculation showed that there was something, I forgot the exact number, it might have been like a 1 in 10 chance that it would collide with Earth on April 13th, 2029. April 13th, which by the way, is a Friday, the 13th. And so this is the size of the Rose Bowl, this thing. And it would be the biggest thing ever known to hit Earth in recorded history. Not as big as the dinosaurs, but during human occupation of the world, this would be the biggest thing we would know. So better data came along, and we learned it would not hit us then, but it could hit us the next time around if it threads a keyhole, a very narrow set of orbits. If it has one of those trajectories, Earth's gravity on it would be just right. Earth's gravity on it would be just wrong, okay? to bend it in such a way so that 7 years later, it will hit Earth. So you want to make sure this does not go through the keyhole. And we have sort of top people working on this, and one of them is sort of a gravitational tractor beam, where if I'm the asteroid and this is the spaceship, you bring a spaceship close to the asteroid, and then their mutual gravity will want them to come together. But you fire some retro rockets to prevent that. And each time you fire the retro rockets, you're effectively tugging the asteroid out of harm's way. gravitationally. You don't have to tug it by much. You move it sideways a little, that amount continues to drift, and it will miss Earth entirely. So this would be a mission of the right timetable to design, build, and send to Apophis to save the Earth. That's what Bruce Willis is for in this case. If it goes through the keyhole, it will hit us April 13th, 2036. That's a Thursday, by the way. Okay. If it goes through the center, by the way, the chances of this now, our data tell us, is several in a million. So you say, oh, not worry about that. But there are people who buy lottery tickets with worse odds than that, expecting to win. So at some point, you got to sit down and pay attention, even if it's several in a million. So if it threads the center of the keyhole, it'll hit it'll hit 500 kilometers west of Santa Monica, plunge into the ocean to a depth of 3 miles, cavitating the ocean to a width of 3 miles. It'll explode, that's the cavitating force, and send a tsunami 50 to 5 stories, so 50 feet tsunami, 5-story tall, that will come to the west coast of North America and basically wipe it clean. Okay? And so this hole in the ocean is what made the first tsunami, but then there's the matter of the hole in the ocean. If you're in an ocean and you have a big hole, what is the first thing you're going to do? You want to fill in the hole. So your water fills in the hole, and the act of doing so splashes into the center with such ferocity that it rises high, falls back down, cavitating the ocean again. This will happen about 40 times before it dampens out completely. And so that means there are about 40 tsunamis that'll come into the coast. And so they'll come in, it'll go through the $1 million Malibu homes, then the next tsunami say, I need your water, please. So then the water goes back out, it takes the home with it, you know? And then the next tsunami comes and brings the home back in a slightly different shape, right? Right? And this continues, and all this, what we would call civilization on the coast, becomes an ablative, churning, destructive force that wipes the entire west coast of the United States clean. Nobody has to die. We would know when this would happen to the minute. 2 people will die. The stupid surfer, okay? That guy's gonna die, okay? First, okay, ready for the second person? The stupid weatherman, okay? You ever see these guys? Bring the camera a little closer. You can see the waves. The people who want to get close to the hurricanes, those weather guys, that's the second person who dies. Everyone else is good to go. Let's move on. Black holes. I told you I have special access to NASA. And so this image is, in fact, the very first ever color image of a black hole here. Notice the detail on the left. You saw it here first. Of course, that's the image you want me to show you, right? That's actually 3-dimensional space squashed to 2 dimensions. But artists try to represent this, but it's a bad day if you're falling into a black hole. In fact, I have a book with that title, Death by Black Hole. And so if you want to find out about it, check it out. It's the experiment you do once in life and in death. Super duper black holes lurk in the centers of galaxies, and they beam rays out. I mean, they're destructive forces in the universe, and they're extraordinary for how much they're able to concentrate energy in a very small place. And if you fall in, you're never coming out. But everything else that tries to get in, it can't. It gets really hot and it radiates out in these jets. So that's a black hole jets. Because matter is trying to get in down the toilet bowl and it all can't fit at the same time. And it heats up in the effort to do so. So I couldn't do this without showing you some black holes. Now, dark matter, dark energy. We don't know what dark matter is. It's 85% of the gravity of the universe is dark matter. Is something we don't know what it is. So we just call it dark matter. We don't know what. The universe has some pressure in the vacuum that's making it accelerate in its expansion against the wishes of gravity. We don't know what that is either. We call that dark energy. This sounds like we know something. We don't. I could call this Fred and Wilma, okay? It doesn't matter. We are dumb stupid about what these two things are, all right? Now, normally that's not a problem, like, until you look at this chart, okay? So everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid in the universe. You're happy about that, apparently. I don't know what that means, you know. Are you applauding my honesty? Are you applauding, you're celebrating the stupidity of our species? We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. That's an idea that came about in the 1970s when there was inflation, severe inflation in our economy. So the word had a lot of currency back then. Now it's like you're inflating a tire, like what are you doing, you know? There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the dark ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later. And that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang Machine. That made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on. The Big Bang, by the way, could fit into a larger story. For example, the multiverse. Big Bang is probably not the whole story. It's probably a piece of a bigger story. So maybe there are multiple Big Bangs. This would give us the multiverse. We don't have data for this, but we have good theoretical and philosophical reasons to think that a multiverse exists. How do you even draw that? Because you need higher dimensions for it. So here are these, each of these bubbles is a universe coming in and out of existence, and we're just one of them. And who knows how many universes there would be. This is very kind of spooky looking, but these are fluctuations, quantum fluctuations in the universe that spawn entire other universes. So it's an intriguing direction. So put this word in your vocabulary and watch it show up in news accounts. It may be that the dark matter is not matter at all. It's the gravity from ordinary matter from a nearby other universe in the multiverse, whose gravitational influence we feel. And here we are, saying, ooh, we have a mysterious gravity, call it dark matter. Really, it's just ordinary matter doing its thing in an adjacent universe. So a multiverse can give you some predictive power, but it's really out there right now, and so we need to give it some room to mature. Now let's take a look at what the rest of the world is doing with science. So, CERN. This is the European Center for Nuclear Research, which I think if you say it in French, comes out in that order, okay? I had a friend of mine, I was at a dinner party, and the person next to me was French, and I tried to get practice pronouncing French words. And so I learned one thing that whole evening, that in French, all letters are silent, okay? Period. That's it. Every letter in French is silent, all right? Start there, and then you do very well, all right? So, CERN, this is where they have the famous Large Hadron Collider. This is like, they're at the limits. It is the highest energy ever attained on Earth. And by the way, we would have done 3 times this energy had Congress not cut the funding for the superconducting supercollider that would have been built in Texas. That was cut back in the early 90s, right around just after peace broke out in Europe, by the way. Physicists are only really useful when we're at war, according to government funding patterns. So they're looking for the Higgs boson and anything else that shows up on the docket. The Higgs is a particle that gives mass to other particles. So it's kind of cool. Some people have called it the God particle, and including physicists. What are they doing over in China? Well, they're building the largest dam in the world, the Three Gorges Dam, and they have a burgeoning aerospace industry growing at 14% a year, 13% a year. Their economy is growing at 10% a year. By the way, what's your interest rate you're getting on your savings account in your bank? 0.003. Okay. Did you get that over here? These get, well, if you go to this other bank, you get 0.005, you know? Yeah, so other countries, different things are happening. Do you know that in Russia, they want to actually send a mission to deflect Apophis? They actually are prepared to fund that. That picture that I drew and did my little dance, that's not funded. That's just ideas on a page. Russia actually wants to fund it. And they invited us to participate. And I said, well, sure. But then I thought about it. I was asked by the NewsHour, what are my top 10 news stories of the year? This was now end of 2009. What are my top 10? I said, I don't have 10 stories, I have 5. Okay, what are they? I said, one of them is Russia inviting us to join them to deflect Apophis. They said, why? I said, here's why. Why is Russia creating the spaceship that's going to deflect Apophis, which, if it hits, wipes out the west coast of the United States? Aren't we the ones who are supposed to fund that mission and then invite others to participate? Isn't this how it has always been before? So that was an important news story for me because that is the beginning of the end. That's where you think you're at the top and people start doing things on their own with or without you. And all of a sudden, you gradually fade to insignificance on the world stage. That was writing on the wall for me when we were not leading that mission. Let's keep going. How about Brazil? If I mention Brazil, what's the first thing you think of? Someone said, bikinis. The guys are saying, yeah, the tongue bikinis, yeah. Soccer, maybe? Okay. This is the American view of Brazil. I understand. It's completely understandable. However, it blinds you to the fact that they have a burgeoning aerospace industry. Do you know that most planes that you fly between regional cities is made and designed in Brazil? You're not thinking this because you're still distracted by bikinis. Brazil has the 3rd largest aerospace industry in the world, employing 18,000 people. It's a $20 billion industry there, and they invented the first airplane that can fly on alcohol. Brazil. Now, we don't do that because we just drink our alcohol. See, that's how that happens. We don't even think to make a plane out of it. So notice the American bias that prevents us from recognizing the rest of the world rising up as we stand there flat-footed. Europe. Let's take a look at pre-Euro currency. I'm intrigued by this. Before the Euro came out, Europe valued, they still do, they value their scientists enough to put them on their currency. Check this out. So you have Tesla in the upper right, Yugoslavia. Some Tesla fans out there. We got Copernicus, and who do we have? We have Marconi down here, and who pioneered radio communication, and we have Saint Schuper right here, not a scientist, but an aviator. And who's the cute little guy? Who's the little boy here? Who's that? Who's that together now? The Little Prince, of course. Who here did not know that that's the Little Prince? Admit it. Okay. So you guys are honest. Everyone else is lying, all right? The Little Prince landed on an asteroid, by the way. The name of that asteroid was called B. Anybody know the rest of the numbers? Oh, okay, that's a good guess. Wrong, but it's a good guess. 210. Actually, I forgot the numbers, but I know it's not that. I think it's B662. Whatever that number is, there's a website you can go to that is all about deflecting asteroids. And it chose the name of Little Prince's asteroid for its website. And so check it out. So you see this, and you can flip over the currency, and it has the iconography of that person's life. So you have some, amazing lightning demonstration there, electrical discharge from Tesla. We've got sort of the sun-centered solar system. There's the tower. We got a biplane there, telescopes. It's all there. We keep going. Hang on. So here's Darwin from England. We got one of his finches. We've got some Darwin fans. What's odd, they always show him with this big old sort of grandpa beard, but he did his greatest work when he was 26. So you can at least put some hair back on his head, But I figured, maybe they figured if he'd show him his 26, no one would think he did, But he was 26 when he did it. This is currency from Romania. They had a total solar eclipse go across their country, and so they thought, let's make some money out of that. So they put the path, and on the flip side, I don't know what that is, right? It's got like an amoeba thing. So an artist gone a little too far, all right? But it's clearly cosmically inspired art. That money, by the way, is made of polymer. It does not rip. Is the future of paper currency. Here we have Al-Hassan, who figured out how sight worked. He's from 1,000 years ago in Baghdad. This is on Iraqi currency. And we got Albert here. He's adopted into Israeli currency. Of course, he was not Israeli, but when you're famous, everyone claims you. See, that's how that works. All of these folks are scientists. Keep going. We've got Euler and Galileo and Gauss and Faraday and Pasteur. All letters are silent. Pasteur. And I don't know what they're doing to this dog here. I'm not even going to ask. We got my boy Ike. And everybody's there. Oh, by the way, if we were to ask, who in the world do we think literally and perhaps stereotypically make the best engineers in the world? Germany, of course, you think about it. It's German engineering. It's a selling point when they sell cars, German engineering, okay? German engineering. Well, so that's 10 Deutschmarks, okay? On the right, that's Carl Friedrich Gauss, brilliant mathematician. Let's zoom in on that currency here. Wait a minute, what is that? Whoa, a mathematical distribution function on the money. Whoa, okay. Look at this. Imagine how different America would be if we had equations on our money. We might still be leading the world in something. Actually, we do have a scientist on our money, don't we? Who's that? Ben Franklin, here he goes. So he's a scientist on money. Surely there's some iconography of his contributions. Let me see. Nope, there's not even a kite, all right? Or there's nothing. I don't even see a lightning rod, all right? So clearly that's not why he's on the money. He's on the money because he's a founding father, not because he was a scientist. In fact, he was one of the most famous scientists of his day in his researches in electricity. Ben Franklin. There's something called naming rights that matters. It matters to cultures. Let's first take a look at this familiar chart of boxes. Some of you are getting the shakes here, I see. Haven't seen it since high school, have you? Okay. The periodic table of elements, it's color-coded. I have a cool program on my computer where you can color-code them differently. Let's color-code by melting point. How about that? Ooh. It's like there were 7 orgasms in the audience when they saw this. I'm certain of it. Okay. Chemistry geeks all the way. So, your highest melting point is more red and lowest. So your lowest melting point is actually helium. Your highest melting point is carbon in the upper right. But there's a group here. So you have wolfram, rhenium, and osmium. Wolfram, otherwise known as tungsten, had Edison access to, if he had access to this chart, he would have found tungsten immediately. Most of his experiments were sort of just trial and error. He could have gone straight to tungsten, put it in his light bulb, and he would have been good to go. So it's an interesting way to organize this. I could do it by discovery date. This is before any element was actually discovered by anybody, and so it just lists the elements known to the ancients. Iron, copper, silver, gold, lead, bismuth, sulfur, carbon. We can slide the date forward, and now we're up to 1776. And so this is the entire periodic table of elements, which wasn't yet organized in that form, at the year of our Declaration of Independence. There's like a dozen elements there. That's it. We also knew about hydrogen, discovered 1766. So these elements are coming up and along, and I can keep going. This is 1869, starting to take shape. And so just giving a sense that you can play with this diagram. Now what I'm going to do now is put the flag of the country that discovered each element. Okay? So let's check out what that looks like. Ooh, that's kind of cool. Okay, notice the right-hand column. You see the Union Jack there, very proud column in the UK. Helium, neon, argon, krypton, xenon. This line of elements are the noble gases. Do you know why they're called noble gases? Because the British discovered them, and they learned that these elements don't combine with any other. And in their social structures, the noble class does not associate with any other. It's little facts like that that reminds me of why we fought a war to get out of England. Their culture is writ on the iconography of the periodic table of elements, the noble gases. Well, America is nowhere to be found up there because we weren't even a country when most of these elements were founded. But when we did become a country and Congress knew that physics, which specializes in matter, motion, and energy, might matter for war, particle accelerators were funded without limit. And it's out of these particle accelerators that we then take out the top end of the periodic table. That's where all of these came from. This is Germany discovered uranium. It's named after the planet Uranus, an element discovered shortly after the planet was in the sky. They knew that's an important, elements are important, so they want to name them something cosmic, Uranus. Neptunium, guess who that's named after? Neptune. Pu. Plutonium. Pluto gets discovered in 1930. This element gets discovered in 1940. It's right in line with Uranus, Neptune. They name it Pluto on the false pretense that it was a bona fide planet. Pluto got on there on false pretense. But look at this. We discover all these, so we get to name them. This is Americium, named after America. This is Californium. This is Berkeleyum. Right? These are places where you have particle accelerators discovering elements. It's naming rights. Other naming rights. Let's go back a little bit. September 11th, 2001, day we all remember. This happened 4 blocks from my residence. These are camcorder shots from my window. This is the North Tower on fire. The South Tower had just been hit about the 20th of a second before this frame was taken. You can see a piece of it punching out and the shadow of that. This is before the atomized fuel ignited, so it's really just the kinetic energy of the ship coming through. If you've never been to New York, just so you understand, this black building on the left is a 50-story hotel, all right? And the towers are 107 stories each. Why am I showing you this? Well, let me just get through it first. So the jet fuel ignites, creates a deflagration wave, and there it is engulfing the entire, and that's the remnants of the plane and people and everything else, office, furniture coming out the side. Within an hour of that, the towers are just gone, all right? And this is the dust cloud that came after it. So this is the street on which I live. So this is 65 minutes after it collapsed. And so this is going on. Shortly after this, President Bush, in an attempt to sort of distinguish we from they, utters the following sentence. And this was before I was on his Rolodex, so I could have helped him out here, you know. I could have said, no, don't say that, okay? So he says, with loose quoting of biblical Genesis, he says, our God is the God who named the stars. Now, first of all, it's the same God, okay? God of Islam and God of the Old Testament. It's the same. Allah is the same as the God of the Old. It's the same. So hold that aside for the moment. Hold that aside. What he did not know is that of all stars that have names, 2/3 of them have Arabic star names, okay? Now, I don't think that's the point he wanted to make. I think he didn't quite get that. And so, here they go. I mean, it just goes on and on and on and on. Not all stars have names, but 2/3 of those that do have names have Arabic names. There we go. Okay? There they go. And you might say, well, how did this come to pass? Where did that come from? What was going on? Because if you think of the Middle East now, and it's not where you're not saying, hey, these are folks naming stars. You go back 1,000 years, Islam, 800 to 1100. In that period, it's generally called the golden age of Islam, of Islamic science. Golden age, there was no greater golden age in the history of the world before or after. When you look at the sum of advances that came out of that period in Baghdad, algebra was invented in that period. Algebra is itself an Arabic word. Algorithm is an Arabic word. Our numerals are Arabic numerals. You ever wonder why? You ever stop and think why they're called Arabic numerals? In that period, mathematics took great leaps and bounds. Agriculture, engineering, medicine, navigation. Star maps were made to assist navigation. Astrolabes were crafted. Then it all stopped. It ended. If you're a historian, typically you focus on history as marked by changes of kings and leaders and wars. That's the lens through which many historians look at the past. And so if you ask people, they'll say, oh, the Mongols sacked Baghdad, and so that's why it all ended. If that were the only force operating, then later, when the Islamic culture rose, you would still see this tradition of scientific innovation. But it has not recovered. It has not come back at all compared to what was going on in that 300 years. And what you do is you read the writings of al-Ghazali, who is a Muslim cleric, and he was to Islam what St. Augustine was to Christianity. What he did was he taught you how to be a good Muslim. He taught you how to read the Quran and how to obey the commands, because back then people were just interpreting it for themselves. He came along, he was an academic scholar. He interpreted the Quran. He said, this is how you must do it. First had social influence and then political and cultural influence. And basically his interpretation took over. And in that interpretation, it included the perspective that the manipulation of numbers is the work of the devil. This cuts the kneecaps out of any mathematical advances that would unfold. Math is the language of the universe. If you take that out of your personal equation, you no longer contribute to the advance of human understanding of that universe. And that absence of Muslim presence in the frontier of science persists to this day. Take a look at the Nobel Prize from 1900 to 2010. I can do this for the Jews, for example. How many Jews in the world? There's like 15 million tops, 15 million out of 7 billion people. These are the numbers of Jews who have won the Nobel Prize in the sciences. 25% of the Nobel Prizes. We have a Jewish person in the audience. Congratulations. Okay, fine. Okay. This is rightly something to be extraordinarily proud of. The traditions of Jews in the 20th century is one of education and scholarship. In earlier centuries, it was one of very strict sort of study of the Torah. Did not involve the natural world. This was a later emergence of the Jewish culture to exhibit this. Let's look at the numbers for Islam. So these are Jews. There are 15 million Jews, 25% of the Nobel Prizes. There is 1.3 billion Muslims in the world. These are the numbers. 2.5. Okay, I'll give you 3 if you really want to include economics as a full number there, okay? If you got to give it a full number, okay. Now, for me, by the way, you can analyze this in any number of ways. There are 50 times the number of Nobel Prizes, 1/80th the population. There's 4,000 times the impact. I lose sleep at night with the question, how many secrets of the universe lay undiscovered, because 1.3 billion people who in an ancestral time would have participated in this enterprise and are now not. That's what I think of as a scientist. Whole populations. By the way, there are other populations that never contributed. I'm not going to them and blaming them. I'm talking about a population that already did contribute. It's in the cultural heritage already. All we're asking is to resurrect it. It has not happened. Okay, that's fine. But how about science in America? Uh-oh. Okay, let's see where this takes us. There's enough older folks in here, old folks. You remember? Raise your hand if you're an old folk. Raise your hand. There you go. Thank you. You remember the day when we used to dream about tomorrow, don't you? You remember every week there'd be some article in the newspaper, in the magazine, the city of tomorrow, transportation of tomorrow, the kitchen of tomorrow. Anyone younger than 30 doesn't even know what tomorrow is. They can't even pronounce the word, all right? Sorry for the low res on this picture, but it doesn't matter. That's how we used to think of tomorrow. This was the future in 1988, right? This is drawn in the 1950s, in 60s, thinking about the 1960s, thinking about the 1980s. Let's take a close look at what's going on in America. I think we have fear of numbers. For example, okay, here goes one. Maybe it's not fear, maybe it's ignorance of numbers. Okay. Science illiteracy is rampant in our culture.
Who was it?
I'm not telling. I've changed my views 360. If you don't remember what 360 degrees is, it is that, okay? Now, I wonder, maybe the congressperson did do that. Exactly. Maybe they're just trying to fool you. Maybe they're trying to make you think they changed their mind, but they did not, okay? I'd have more respect for them lying with correct math, okay? But I'm pretty sure he was telling the truth with math ignorance. Half the schools in the district are below average. You know, that's kind of what an average sort of is, right? About half below. That's kind of what, not exactly maybe, but pretty much so. Technically, that would be, what would that be? The median, technically, but still. What the journalist probably meant to say was half the schools are below standards or below grade level, but they said below average, which meant they were mathematically illiterate. If that were actually true, something would be wrong with the state of mathematics. Here's one, a little more subtle. 80% of airplane crash survivors had studied the locations of the exit doors on takeoff. So you say, well, I'm going to study where the exit doors are. Because I want to be in that 80%. That's a good percentage to be in, isn't it? That's good. So, but think about this. Wait, what's about So think about, so here, let me just posit a question to you. Suppose 100% of the dead people study the locations of the exit doors on takeoff. You would never know because they're dead, all right? So this statistic is basically meaningless to act upon. That's all I'm saying. I'm just saying. This one, you get this a lot. The state lottery is a tax on the poor. We've heard this because poor people spend a disproportionate fraction of their income on state lotteries. Does Washington have a state lottery? Every state has. But really, I don't think of it this way. I think of it as the state lottery is a tax on all those people who never did well in their math class. That's how I think about it. How about buildings? You go into buildings. 80% of all buildings are missing a 13th floor. 7, 8, 9, 10, 11, 12, 14, 15, 16. I feel like going into all these elevators with a Sharpie, crossing out the floor, putting it, and say, that's the 13th floor. You're not fooling anybody. This is 21st century America, and we have people afraid of the number 13. And what happens when you get to lobby and then you go to floors below the lobby? What do they call them? B for basement, SB, sub SBB. Can I buy a vowel, please? Like, what are you doing there? We have perfectly good nomenclature for going below the lobby level. They're called negative numbers, okay? We know how to do this. It is well understood. But of course, this is America. There is a place in the world that has negative numbers. Oh, it's in Germany. Oh my gosh. Oh, Oh, by the way, is this a science museum? No, it's a history museum. Germany. That's a closer look in case you missed it. Okay? There's also bad physics. All right? Now, this illustration requires an explanation. This is an ad for Holiday Inn. Now, admittedly, this is Holiday Inn England rather than Holiday Inn America. But Holiday Inn is an American company. Now, this is an ad for a new marketing plan where you can have what they're calling bed warmers pre-warm your bed for you before you go to sleep at night. Okay, so the people on either side are the bed warmers. Now, of course, he's looking at her and not him. Just interesting fact there. But this is a thermodynamically pointless exercise because the only way you're going to get the body heat from those two people is if they are naked in your bed. But for reasons of sanitation, they are not only fully clothed, they are fully insulated. If you're insulated, your heat is not coming out. It stays within all of your clothing, so they are not heating the bed at all. Whoever thought this up never took Physics 101. If they did, then these two people would be naked. I got another one. Is there any Bayer, the Bayer Corporation, do they have plants out here? No? Good, okay. This is an ad from Bayer where they are boasting that they send their scientists into the schools to help out. So Bayer employees volunteer in a hands-on, inquiry-based program, making science make sense, to help kids develop a lasting passion for science. You're on. Try to get them interested. Now, first of all, they've got a black kid and a woman. Like, apparently these are the problem cases that you got to get interested. Like, how about the white kid with the tattoo who just got off the motorcycle? Where's he? Okay? But, okay, so these are the problem kids, okay? The woman and the black kid. All right, let's see what we're trying to get them interested in. Try to get them interested in why lighter things fall faster than heavier things. That's a tough one, huh? It's tough because that doesn't happen in this universe. Yes, they would finally fix the ad. You're on. Try to get them interested in why lighter things fall as fast as heavier things. That's the Galilean experiment. But what's clear is that previous ad was written by somebody. Nobody caught the error. It was typeset. It was laid out. It was printed. No one caught the error. Nobody in the entire chain of command, from the first person who composed it to the copy editor of the magazine ad. So what's clear is that whole chain of people are the ones who should be in this photo, and not these two kids. The American Physical Society meets, it's sort of my professional physics organization, and choose a city. Occasionally, this one time we met in Las Vegas, but this is what happened here. Vegas asked them never to return to the city. We're talking about America, people. Bad engineering. What is this? Okay, levees broke in New Orleans, 2005. You know, if you read accounts of this, they say, oh, Katrina came in and Hurricane Katrina, bad hurricane. Excuse me, pause, back up. Do you know Katrina was category 5 in the Gulf? On landfall, it was category 3. It had already passed over New Orleans. People were sweeping up some of the broken branches in the street. Then the levees broke. The city survived the hurricane just fine. What it is they didn't survive was faulty engineering. That was the problem in 2005. And I submit to you that you look at these images and people hoping to get rescued from their rooftops, and you ask yourself, what country is this? Some of us who are old enough, we used to see film loops of third world countries where you see an absence of infrastructure, people towing, their belongings with an ox through mud. And you say, oh, that's the third world. We live in America. What country is this? In the middle of Manhattan, a steam pipe explodes. People died. Steam? Don't we know how to move steam from one place to another? Wait a minute, we're actually still using steam? What? Okay. I'm not going far back in time to get these stories. Bridge collapses. I-35, Minnesota. A bridge collapsed? You go through Europe, there's still bridges standing from the Roman Empire. We can't put a bridge over that, all right? That's not a river, this is a brook, all right? What country is this? Let's go to Los Angeles. Trains collide. People get hurt. Some people die. You think we would have figured this one out. A train comes this way, you don't send another train the opposite direction on the same track. That would be like commandment number 1. All right, Railroads 101. A crane collapsed. Back in New York, a crane collapsed. What, you can't hold up a crane? What country is this? Hurricanes come. We say, run! Now, here's what's interesting. I think these people already know about this, okay? So, this is useless information to all these people. Now, here's what happens. If you don't have scientists and engineers in your midst, when a hurricane comes or some kind of natural disaster, your first thought is stockpile food and run. But if you're an engineer or a scientist and the disaster's coming, you say, how can I avert that disaster? I foresee a day where a hurricane forms in the Gulf. You put in some kind of apparatus that taps the energy of that hurricane, and that energy drives the electricity of the city that would otherwise be destroyed by the hurricane had it continued to go through. That's the kind of thinking that needs to go on in this world. What country is this? I'm not going far back in time here. This is, yesterday's news. What country are we living in? There's more what's going on. Profound science illiteracy in this country. Here's a book that I read before I came here. I read it in its entirety. I heeded its advice. I wanted to make sure I showed up for you this evening. So someone has to write this book. An editor says, hey, that's a good idea for a book. A publisher publishes it, they put it on the shelf, and then people buy it. How about this one? And this is one. How to Survive 2012. Tactics and survival places for the coming pole shift. Pole shift? Where'd they get that from? The pole? The end of the world? In there is the Mayan calendar. Because clearly the Mayans knew more about astrophysics than any of us do today. Clearly. And wait a minute. Next Saturday. Whoa, next Saturday. Whoa. What country is this? What millennium is this? So what's interesting is originally they said the world was going to end May 21st, but then it was revised, and so apparently the 21st is only Judgment Day, so Jesus is coming on the 21st, and I'm guessing that he's really pissed, okay? So, at human beings. So 5 months later is the asserted end of the world, as evidenced right here, the end of the world, and there's not much sand left in that clock. You can translate this into any language. There's an audio reading of this, and you can get the printer-friendly PDF version of this account. What country is this? I'll show you where this. Answering the question, did human beings, as we know them, develop from an earlier species of animals? This is simply evolution by natural selection. So if you're this, so this is countries ranked. Sort of Western countries and countries that are otherwise developed by the modern use of that word. So if you're this sort of the green bar, it means yes to that question, which means that you're convinced by evolution. If you're this sort of amber bar on the right, it means no. And if you're the white in between, it means you're unsure. So America's got to be up there somewhere. No, Iceland, Denmark, Sweden, France, Japan, Britain, Norway, Belgium, Spain, Germany, Italy, Netherlands, Hungary, Luxembourg, Iceland, Slovenia, Finland, Czech Republic, Estonia, Portugal, Malta, Switzerland, Slavic Republic, Poland, Austria, Croatia, Romania, Greece, Bulgaria, Lithuania, Latvia, Cyprus, United States of America, edging out Turkey by a nose. There it is. What country is this? Maybe we should just move back to the caves. Let's analyze it a little further. Here's a map. This map has the area of each country apportioned according to their surface area on a globe, which means it's a normal map. Okay, so what we're about to do is morph the area of each country according to how much peer-reviewed science research is conducted in that country. Okay, let's do that. So this is a measure of who's doing the most science in the world. Some countries will shrink relative to that area you see here. Others will expand depending on how active they are in science. So let's check out what happens when we do this. Whoa, the United States is sitting fat and pretty there, I'd say. That's America, yeah. Yeah, okay. Wait, what's that big purple region away? Whoa, what was that? What's that purple? Whoa. What country is that? Japan, kicking major science butt on the map right there. One of the great tragedies is Africa shrinking to nothing in area on this chart. Compared with the area it actually occupies in the world, that is a modern day tragedy right there, given the natural resources that are prevalent within it. Europe is huge. They split formerly Eastern Europe, that's in blue, from Western Europe, that's in those shades of pink. So, and there you have Brazil, that's the aerospace industry kicking in there. All right, you look at this, you say, hey, we're doing pretty good. Tyson, what are you complaining about? Okay? This is the wrong map. What you want to look at is not how much science is going on, no. You want to look at the change in how much science is going on from the year 2000 to 2010. That's the trend line. That is the future of the world. Compare the difference in published research papers in all sciences between 2000 and 2010, and you get this. Europe is even bigger. Japan is even bigger. China is huge. Africa is even smaller. This is the changing landscape of the world. As everyone else understands the value of innovative investments in science and technology in ways that we do not, we slowly fade. This is the fading that worried me when Russia says, oh, you guys want to join us for a mission that will save your West Coast? You say, well, sure, well, we got our space program. We lead the world in space. How about space? We've got some faulty memory going on. One of them is that we're space pioneers. That's a faulty memory. Okay? Yuri Gagarin was launched into orbit 50 years ago, April 12th. Okay? We all know that. Did you know, however, that he, and I tweeted this, by the way, he was the fourth mammal to achieve this feat after dogs, guinea pig, and mice. Then we sent, a human, they all Russian, a Russian dog, Laika, guinea pig and mice, then Yuri Gagarin. So let's look at the full list. Dogs, in order, dogs, guinea pigs, mice, Russian human, chimpanzee, American human. Does that sound like we're pioneers here? We come behind Russian mice. The Russians did all this first. They came up with the rocket formula, for goodness sake. This is the formula that tells you that most of the fuel in your rocket that's yet to be burned requires fuel to lift it to a place so that you can later on burn it. That's why the Saturn V rocket, 32 stories tall, the astronauts are in the up a little bitty bit, and all the rest is a bomb, basically. All right? First satellite, first animal, first human, first woman, first black person in space, first to land on the moon with the robots, first lunar rover. They photographed the far side of the moon, Earthrise from the moon, Venus, Mars, spacewalk. Now, we have a few firsts. We have a couple. First, space docking. First to land on the moon. We crossed the asteroid belt first. First to achieve hyperbolic velocity, velocity that escapes the solar system. Okay, but still, this is hardly what you would call pioneering behavior. Let's see what NASA's been up to. NASA, that's how you spell it, NASA, right there. NASA actually doesn't get much money. People think it gets a lot of money. Well, that's actually quite a compliment to NASA. Most people think NASA gets 10% of the federal budget, 20%, maybe as little as 5% of the federal budget. What NASA actually gets is 1/2 of 1% of the federal budget, 0.005 times the federal budget. So this is 1/2 of 1%, 1/2 of a penny on your tax dollar. If you pull out a dollar bill and you cut 1/2 of 1% of its width, you don't even get into the ink. You're still in the outer border of that bill. That is NASA's annual budget, and it pays for the space shuttle, all launch vehicles, the Mars rovers, Hubble, space station, astronauts, NASA centers, space missions, all of it. So the people say, why are you spending money up there and not down here? That's not that much money. What are you saying? What, you think if we took this money from the federal, if you said, let's not spend this because we have problems on Earth. Oh, okay, let's take this and give it to the problems on Earth. Is that going to solve those problems? You think this little slidgen of the, but they put it back as this. Let me keep going here. We somehow believe that we were leaders and visionaries in space. Here's an interesting quote. I'm not that interested in space. I wonder who said that. John Kennedy to James Webb in 1962. That's who said that. How about this quote? It's Kennedy again. This is, whether we like it or not, a race. Everything we do ought to be tied to getting to the moon. So it had nothing to do with we're explorers, we're visionaries, where's our DNA, we're American. It's like, no, we're at war. Russia is beating us in every measurable way. So So I'm angry. I'm angry. So I have to calm down and then sort of take a cleansing breath and bring to you the cosmic perspective. Now, okay. So now the cosmic perspective is not always make you feel big. Most of the time, it makes you feel little. So I'm just warning you before you start applauding. Okay. Now that dude up there, he might applaud no matter what. Okay. Who was happy to learn how stupid we are about the universe. My favorite planet, Saturn, viewed from the front. But let's go behind it and view it with one of our satellites, and you'll view Saturn eclipsing the sun. One of the most stunning images ever to come out of the NASA portfolio. The sun is behind Saturn in this image. And the sunlight is illuminating the outer rim of the upper clouds of the ball. And you see the ring system illuminated from behind Saturn. Now, we're looking towards the inner solar system because the sun is behind Saturn. Saturn's far away. Saturn is 10 times farther from the sun than Earth is. So let's zoom in a bit. I see something there. Wait, what's that? Oh, there's a little speck. Oh, that's Earth, by the way. Sorry, I meant to tell you that. That little speck, that 4-pixel speck, is planet Earth. You want to get a feeling for that, go listen to Carl Sagan recite his own words about a pale blue dot, where on that speck is everyone you've ever known, all wars that have been fought over temporary demarcations in soil that exists on that speck. How full of ourselves we are when viewed only from Earth. Other ways to view this, let me give you an updated tree of life. That's an updated tree of life done in a circular pattern. The beginning of time is in the center, and time extends outward. There's 3,000 species, names of 3,000 species written on the outer rim, but that's only like 1/10 of 1% of the known species. So these are just sort of representative species there. And you see the continuous branching, and each branch contains a major sort of commonality of DNA, but in the end, everything comes back because we're all connected. So you say, well, where are we? Oh, okay, we must be up in the animals part, because we're not fungi, and we're not plants, I'm pretty sure of that. So let's zoom into that. Oh, so you are there. Oh, there we are. There we are. Oh, no, I got to get closer. Wait, got to get even closer. Oh, yep, let me get a little even closer. There we go, Homo sapiens. There we go, all pixelated out. There we go. There we go. By the way, seeing trees of life written this way tell us with great strength that it's not we who dominate the earth, we're sort of participants in an unfolding of the earth with all the other life forms. And more on that in a moment. I want to offer you, in this denouement of my presentation, just a sense of where we are in the universe. And the only way I can do that is to get you familiar with numbers and their size. So here's the number 1 written 3 ways, needs no introduction. If you're unfamiliar with scientific notation, the 0, that's sort of the exponent there, tells you how many places to the right. The decimal has moved to the right of the 1, and it hasn't moved at all, so it's 0, right? A familiar number. Let's go up by a factor of 1,000. The decimals moved 3 places. You got 10 to the 3rd, 1,000, metric prefix kilo. I note here and now that drug dealers were metric long before Americans were, okay? Kilos, it was like, first time I ever heard the word kilo were drug busts. I say, wow, they're metric. That's cool. That's all I thought. I was a nerd kid, so that was an okay thought. It wasn't 50 pounds of cocaine. No, they're measuring it in metric. Go up by another factor of 1,000, you get 1,000,000. one with 6 zeros. Remember when computer strength was measured in megabytes and mega? There are 8 million people living in New York. 8 of these are my neighbors in New York. Go up by another factor of 1,000, you get to 1 billion. Carl Sagan's favorite number. In fact, if you bring your chin out and say the word billion, it sounds beautiful. We'll do it together on 3. Ready? First, stick your chin out. Okay, 1, 2, 3, billion. Oh, isn't that beautiful? That's just beautiful. That's just beautiful. That's a beautiful thing. Billion. That's a fun number. Anyone here 31 years old? Raise your hand. Got to be a few of you. Very nice. In this year of your life, you will live your billionth second. Yes, I'm geeky enough to have calculated this. 31 years, 259 days, 1 hour, 46 minutes, and 40 seconds. But you have to account for leap days and leap seconds, okay? I'm going to try to make an app that'll do this, but I haven't done it yet. I've been busy doing other things. But I celebrated my own billionth second with a really small glass of champagne. 50 of these billions. Let's see, I think a neighbor of yours, he's a neighbor, right? Isn't he? He's like, you see him around town, I presume? Not, okay. His net worth is like $50 billion, plus or minus. I don't know if you know how much that is. I don't believe you know. You don't. In fact, I'm certain you don't, because I'm going to tell you. I will tell you how rich this man is. First of all, I'm charmed by the fact that the patron saint of geeks is the richest man in the world. That's a different world than it was when the richest people were sort of oil barons and steel barons. It's like a geek is the richest guy in the world. That's kind of cool. But 50 billion, I did this math because I walk along the street. You know, I have a job and I own a home, and I'm walking down the street and I see a coin in the street. My question to myself is, what is the smallest denomination coin that I'll bend down and pick up? Okay? Given the fact that I have a job and I own a home. So, the penny is staying. I'm not getting the penny. The nickel, no, I'm not getting the nickel. Dime, if I'm not in a hurry, I'm picking up the dime. Okay? A quarter, well, that's good for parking meters and laundry. Plus, it's a quarter, right? So I'm picking up the quarter. So for me, the boundary between picking up the coin and not is between a dime and a quarter. So I figured, let me ratio this up to that wealth and ask, how much money has to be laying in the street for Bill Gates to be too busy to pick it up? It's $45,000, okay? That's what it is. 45,000, I said, too busy. Somebody else get that. That's how rich the man is, in case you didn't know. Let's go to 100 billion. I've seen this number before. Where have I seen it? McDonald's. Actually, they had like a Y2K problem with their accounting. They didn't have a third spot. So they went to 99. Then after that, they just said, after Carl Sagan visited them, what do they now say? Billions and billions, of course. But I remember when they had 100 billion, if you lay those hamburgers end to end, you can do this. Start right here in Seattle. Go right across the Pacific Ocean. Float them on a little plate. And you can come around back and come right back here to Seattle. Across the Europe, the Atlantic, the United States, and come right back here with your 100 billion hamburgers, and you can do that 52 times. Then with what's left over, you can stack them with what's left over and make a stack high enough to reach the moon and back. Then you would have laid out your 100 billion hamburgers. This is terrifying news to cows, all right? I just want you to know. Also 100 billion. Do you realize that in 1 linear centimeter of your lower colon lives and works 100 billion microbes, which is a bigger number, about the same number, as the total number of human beings who have ever lived. That's what's going on in your lower intestine. Yet we like to think that we're actually in charge of things. But from the point of view of the bacteria, we are just a warm, dark, anaerobic location for fecal matter. It's just a reality check here, okay? We tend to make things nicer for ourselves with words. Like what's the book that has optical illusions? Who doesn't like a good optical illusion? Of course, that's not what they are. They're brain failures. That's what it is. Oh, I can't figure it out. Is the line in or out of the page? Oh my gosh. Those books should be called brain failures. A few more, and then we got a trillion. By the way, can you count to a trillion? Where's my 31-year-old? Yeah, so if you counted one number per second since birth, you'd just be getting to a billion about now. So if you wanted to get to a trillion, which is 1,000 times bigger than a billion, how many years would that take you? 31,000 years, right? Simple math. It takes 31 years to count to a billion, 31,000 to count to a trillion, so definitely don't try that at home. A trillion seconds ago, somebody painted those on a cave in Lascaux, France. France. Have you ever heard the joke? It's like a really stupid, self-deprecating joke. They say, the French, they don't even have a word for entrepreneur. Can only be spoken by a monolingual American. So we have billion, trillion. What's the next number here? Quadrillion. Someone said zillion? No, almost. Quadrillion. That's about 100 quadrillion is the number of sounds and words ever uttered by all humans who have ever lived. So these numbers are getting really huge, really fast. Billion, trillion, quadrillion. What's next? Quintillion. There's one of my favorite numbers. About the number of grains of sand on an average beach. Even the sand that comes home in your crotch, I counted those, add all those up, they're in this number. Million, billion, quadrillion, quintillion, sextillion, a 1 with 21 zeros. Of what possible significance can this number have? That is the estimated number of stars in the universe. Stars in the universe. Some people, this depresses them. Among them, this gentleman, a professor of psychology at the University of Pennsylvania. We opened a space show 11 years ago that was a zoom out from Earth. And Earth shrunk down, and the solar system shrunk down, and it just became one of the stars in the background field. Then our whole galaxy shrunk down, and it was just one of countless other galaxies in the universe. He saw that space show. I am assistant professor of social cultural psychology, University of Pennsylvania. I want to conduct a research project in collaboration with the planetarium. My research focuses on the psychological experiences associated with feelings of insignificance. I'm thinking, damn, bummer of a job. What? What's he like when he comes home? Honey, I'm home. How was work today? Miserable. How does that work? How do you even do this? I recently saw the space show at the planetarium, and needless to say, it was the most dramatic elicitor of feelings of smallness and insignificance that I have yet encountered. He wanted to conduct a survey. I'd be grateful if we can conduct a simple questionnaire survey at the planetarium. They want to interview people going in and then coming out of the space shuttle. I submit to you that if you go in feeling large and come out feeling small, it meant you went in with an ego unjustifiably high to begin with. The problem is not in the universe. The problem is within you. That's what I submit. Let's take a look at something real quick. Cosmic abundances of the elements, ranking them top to bottom, most abundant to least. Number 1 in the universe, hydrogen. Cool. Number 2, helium. Very nice. Number 3, oxygen. 4, carbon. 5, nitrogen. My favorite element of them all, other. Okay, so then, how about life on Earth? What's the ranking of elements in life on Earth? Well, all life contains water of some kind or another. Water is made of hydrogen and oxygen. So hydrogen's got to be pretty high up there. Sure enough, it's the number 1 element in life on Earth. What's next? Oh, we don't actually have helium. Remember, helium is a noble gas. It does not interact with anything. So helium is not in life on Earth. You could inhale it, then you sound like Mickey Mouse. By the way, Mickey owned Pluto, okay? Which is an abomination of the mammalian order. Dogs eat mice, okay? So I had to get to the bottom of that. I called up Disney. I said, how is it that a mouse owns a dog? What goes on there? And he said, okay, if you are a creature in the Disney pantheon and you don't wear clothes, you can be owned by others who do. Pluto is butt naked and walks on all fours and does not speak, whereas Goofy, also a dog, wears clothes, walks bipedally, speaks, owns a home, pays rent. That's the difference, okay? I know you were burning to know this. Okay, next most abundant ingredient, life on Earth, oxygen. Next, carbon, in order. Next, nitrogen. And together, class? Other. We are 1 for 1 the same ingredients that appear in the universe. If we were made of like an isotope of bismuth, you might say, hey, we're different. We got something different going on down here. Excuse me, we are the same as the universe. And these elements are forged in the centers of stars. This is actually an image of the center of the galaxy, but there's stars within here that forge those elements, explode from what we call supernova explosions, scattering their enriched guts across the galaxy, enabling freshly born star systems to contain the basic ingredients of life itself. And this is going on in every single galaxy across the universe. We can dim the lights for the last 2 images. This is our nearest large galaxy called the Andromeda Galaxy. It happens to be among the stars of the constellation Andromeda. That fuzzy spiral contains 400 billion stars. These other stars you see in the picture are sitting on our nose in our own Milky Way. It's as though we're looking past a screen door through the void of intergalactic space to another galaxy. If you pull out the power of the Hubble Space Telescope and say, I'm not going to look at this big galaxy, I want to look at an uninteresting corner of the dark night sky and show me what's there, this is what shows up. This image has 3 stars in it that happen to be sitting on our nose. One of them, if you can still see me, is right here. They have spikes. Another one is directly over me here, and there's one at the top. Every other smudge, every other shape in this image is an entire galaxy, from nearby to the distant universe. Every single splotch on this image. This is the Hubble Ultra Deep Field. That's what it's called. And you sit here and gaze upon it and recognize that every smudge is like our own Milky Way, containing hundreds of billions of stars. some of which are forging these heavy elements that comprise life, exploding, scattering themselves into their own galaxies. And it is this knowledge that we have of the universe, and our knowledge that we have of chemistry, and our knowledge that we have of biology that allows us to derive the conclusion that no, we are not apart and separate from this universe. We are one with it. I can say one better than that. Not only are we one with it, because these elements are forged in the universe and they become part of life as we know it. It's not simply the fact that we are in the universe, but, ladies and gentlemen, the universe is in us. And I know of no more profound understanding or revelation that modern science can deliver but that. And for me, that makes me feel large, not small. Thank you all for this evening. Sorry I went a little long. Because I wanted to make sure we have time for Q&A. And I was looking at the clock. We actually have a little bit of time. I'm actually flying out tonight back to New York. But I have maybe 20 minutes or so. I think that's enough to get some good sort of Q&A action here. Because there's one huge aisle. I mean, there is no aisle in the middle. There's one huge row. If you just raise your hand, I will call on you, and I'll list just, this room has awesome acoustics. If no one else can hear it, I'll just repeat your question. And we'll be folding in questions that have been texted to the special text line that was given to you earlier. Ma'am, right here, yes. And I'll repeat the question. She watches, what? There's a lot of information. She watches Nova Science Now on a regular basis. She's a chemist and she's Canadian. Okay, I'm trying to stay with you here. Okay, go on. She's accustomed to the metric system, yes. But all of you are amassing at the border between Canada and America. Are you planning an invasion? Because we have top people checking this out. I just want you to know. Okay, go on. Okay, she's complaining that in my show, Nova Science Now, that we give American units often, and she's Canadian, and she wants metric units. Okay, I will take that under advisement. I think I have a slightly different pedagogical outlook, okay? In America, if you know the metric system, you probably don't need to watch Nova Science Now. So I'm really just trying to reach the people who need the science. And I do have a policy, an editorial policy. I'm executive editor of the series. Editorial policy on how we invoke one unit or another. We will use metric units if the number is out of scale of your everyday life. All right? So I'm not going to give the diameter of the solar system in feet. All right? But if it's the temperature of a room, I'm not going to give that in Celsius because no one will know what the hell I'm talking about here in America. So that does put a greater burden on you, the Canadian, to adapt to our mysterious ways here in America. Yes, right there. Yes, you.
I write an education blog here in Seattle. What can you do to change the American public school system?
Okay, she writes an education blog here in Seattle and wants to know what I would do to change the public school system. So I'm sad about a couple of things. When I look back on my life, and I've done this experiment, we'll do it here live. I ask of myself, in my life, how many singularly influential teachers have I had out of the 100 or so that I've had since kindergarten, right up through college and graduate school, maybe 200 teachers. How many? And it's maybe 3. And then I thought, am I unusual in this regard? So I started asking around. And I've come to find that nobody has more than 5. Nobody. Typically it's 3, maybe 4. And just a quick show of hands, in your life, how many teachers sort of were singularly impactful on your life? So how many? 5 here, 2, 5, 3. Who's got 8? Who got 8? Oh, it's the guy who was. No. No. Did you grow up in America? Yes. Did you attend public schools? Yes. What city did you grow up in?
Evanston, Illinois.
Oh, Evanston, Illinois. Interesting. Okay, so clearly with the number 8, he's an outlier from the general statistics that we've come up with here. So what I would do is the first appearance of the cloning machine, I will stick those teachers in that machine. They will then become the entire teacher supply of the nation, and that would transform the K through 12 educational system. Now, I'd say that only half jokingly, but why is it that out of 100 teachers, 1 or 2 of them actually made a difference in our lives? I bet those are the teachers I bet for none of those teachers are you saying, boy, that teacher gave a great exam. That's why boy, that homework was awesome. This is what you're saying about those teachers? No, that's not what you're saying. You're saying that they had an energy, they had enthusiasm for their field, that they made you like what they liked, even if you started the class not caring anything about that subject. That's the power that those teachers have. And there's not enough of that in the academic system. And I lose sleep at nights wondering how we can boost the number of those teachers. So that's the slightly unrealistic solution that I have to that problem. Yes, right here, yes.
One.
Second row.
Okay, I've looked at one of your lectures before, and you said that when people get to the limits of their knowledge and they invoke intelligent design, you said those people are no longer useful for you in the lab.
If that's what they do, yes. So the question is, he saw one of my talks where I spoke of when the research scientist, so do you carve your way to the edge of what is known, and so there's a boundary there between what's known and what's unknown. Now you want to push that boundary by asking questions of the unknown, and that's how discovery unfolds. And in that lecture, I commented that there are some people in society who will invoke either a deity or what they call intelligent design as an accounting for things that we don't yet understand, on the premise that we will never understand it. And I asserted that those people are not useful in the laboratory. Whatever it is they do in life, the lab is not a place I need them to be. I need the people in the lab to say, there's something I don't understand, I'm going to solve it. That's a different kind of mentality towards the unknown, and those are the people who make discoveries. Okay. So, we've got a question. Oh yeah, cool. We got a texted question. Go.
What developing technology are you most excited about?
What developing technology am I most excited about? I can't wait until we just find a way to tap energy more effectively from the earth. Every time Earth wants to kill us, it's some expression of energy that the earth is burping up, okay? If it's not a volcano, a tsunami, a hurricane, a tornado, a landslide, this is all energy getting expressed that we're running from. And what I want to do is run towards it with technologies and say, I'm tapping that energy and driving the power of my cities. And that way, I don't have to pull oil out of the ground. How backwards is that? So that's, okay? Another question. What advice would I give students studying astronomy? To keep looking up. Okay, next. That's called a soundbite. Yes. Okay, go on.
In order for the USA to stay competitive in science and as a superpower, how much funding for science does NASA and others have to increase?
Okay, so the United States also recognizes, in spite of my lamenting NASA's low budget, Congress has voted to increase the budget of other science agencies in America, including the National Science Foundation, National Institutes of Health. This is all a good thing. The difference is, of course, when you're in 8th grade, you're not standing up in class saying, when I grow up, I want to be an NSF researcher. That just doesn't happen. That's just not what kids think. The most exposed science we do is NASA science, and that's what kids see all the way down to the cradle. And so if you raise the budgets of the rest of the sciences and don't do it for NASA, then you are undermining the most powerful inspirational force that we've ever come up with. The very fact that people think NASA's budget is bigger than it is the very statement that its expenditures are extraordinarily effective in their impact. In fact, I wanted to start a movement where all agencies get paid, get a budget equal to what people think they're getting paid, okay? If that were the case, NASA's budget would go up by a factor of 10.
One more. Do they classify new exoplanets like they do in Star Trek?
No. Next question. Okay. All right.
What kind of scheme is used?
Okay. It's a really brain dead scheme. The Star Trek classification scheme for exoplanets, which for them are just planets, it's much more advanced. There's a letter. It's a letter designation that references whether there's a nitrogen atmosphere, whether there's life, how it orbits. It's a much more nuanced classification scheme than anything we've yet to come up with, in part because our data are not that good. You need really good, refined data to start dividing things up into their categories. We're not there yet. But I would vote for the Star Trek scheme if we ever had good enough data for that. Do you have another question? No, you don't. Okay. So did you finish your question here? You didn't finish your question. Yes. Go.
What I was going to say is, if you're brought up in a belief system that already invokes intelligent design from when you're little, but you reject that belief system later on, what can you tell people, to help them along in the sciences with that?
If you're brought up in a belief system that prevents you from gaining access to that frontier of discovery, and you transition out of it, there are plenty of religious people who are just fine doing science. And for them, for example, and among them would be Francis Collins. He's a devout Christian, and he's head of the NIH. I mean, for a while he was head of the Genome Project. His significant political influence on the science portfolio of the nation. For him, the science informs his religion rather than vice versa, okay? And so that's probably the most secure posture to take if you want to continue to participate on the frontier of research. If you start having your religion tell you what science you're going to find, the history of that exercise is one of abject failure. And you might as well just go back home, because it's not going to work. The history of that just demonstrates that it doesn't work. So that's how people do it. They've done it. Balcony, yes, right there, sir.
What makes globular clusters stable?
What makes globular clusters stable? Woo. It's got 100,000 stars. And they all like each other because they all feel each other's gravity. And they all have some motion sideways. And so it's this beehive, all gravitationally bound together. Occasionally, you get a couple of stars that have 3 stars, and one has like 2 come together, and a third one sort of zips around and comes out again. And there's an energy transfer. When that happens, you can actually kick a star to have higher than the escape velocity of that system. And so a globular cluster will slowly evaporate into the galaxy, very slowly. They're actually quite tightly bound, but when this happens, it's quite, you can do models of this, and you just see stars interact in a cosmic ballet choreographed by the forces of gravity. And when that unfolds, you see a star get kicked out. In fact, most stars in our galaxy, all models show, were born in a cluster, and the action of nearby stars in a kind of a fly-by looting tends to disrupt these clusters over time. Globular clusters spend most of their time outside of the disk, and so they're not sort of harassed as often by the gravitational field of gas clouds and other stars. So globular clusters just fine. Gravity keeps it nice and tight, and they're beautiful to look at in a telescope.
In the center, is there not move towards a singularity, all the mass?
Oh, at the center of by the way, a globular cluster through a telescope and through a photograph, it looks pretty dense, but the average distance between stars remains huge. It's not so dense that you're going to get some kind of a black hole in the center. It's not like the center of the galaxy, for example, where there's a lot of very dense action going on. Globular clusters, most pathways through it won't even ever hit a star. It's mostly empty space. Yes, more.
How did you pick your major?
How did I pick my major? Okay, so I went alphabetically and I got to astronomy first, and there was. No, I picked my major when I was 9 years old in a family visit to my backyard planetarium, the Hayden Planetarium in New York City. I'm in there as a kid, I sit down, they dim the lights, the stars come out, and I say, oh, that's a nice hoax, because there were countless thousands of stars on that dome, and I knew that wasn't right because I'd seen the sky from the Bronx. There were 12 stars in the night sky, so this couldn't be right. It just couldn't be right. But I said, but I'll let them go with it, I'll just allow this. And I realized later on that this is the real sky, and between age 9 and 11, the universe called me in a way that, in fact, I had no choice in the matter. I am being pulled along by cosmic forces beyond my understanding. So I've been thinking about the universe since age 9. Any 9-year-olds in the audience? There were a couple. I said, there you go, 9-year-old right there. That's a high five in the air. There you go. A couple, he said only one more, but why don't I take 2 and then answer them in half the time? How about that? That should add up. Yes, ma'am.
I'm such a huge fan of you in the planetarium, but you seem so...
Wait, but, oh. She said, I'm such a huge fan of yours and the planetarium, but, okay. Okay, so she just changed her sign here.
You seem so light on your feet. Are you a dancer or are you a dancer?
Oh. She said I seemed light on my feet. Am I a dancer? I at one time in my life, long ago, I was a performing member of 3 different dance companies. And they were like college troupes, not like Bolshoi or something. It was, but they were, we had hard workouts. And if I ever give a talk in a performance space, I'd take off my shoes because how could you not? It's not a lecture hall. So I've longed to be in the dancing shape that I once was, but when I was dancing, I wasn't writing books. So that is simply a chapter in my past. And I quote for you 2 or 3 lines from Desiderata. I am taking kindly the counsel of the years, gracefully surrendering my things of youth. Question right here, yes. Louder!
Do you think that it will ever be possible for a human to travel in time?
Did you guys get that in the upper corner there? Yeah. Awesome acoustics. I don't even need the microphone. Well, in some ways, we're traveling in time now. We just happen to be prisoners of the present in the eternal transition from the past to the future. Oh, he said, give me a real answer, buddy. All right. If this were New York, that would have come out much more threatening than it actually did. It was like, can you give me a real answer? It's like, that was like a wimp threat, okay? So, all right, a real answer. If you travel fast enough, you can actually leap forwards in time. Relativity specifies that you travel a good fraction of the speed of light, time will tick more slowly for you than all your loved ones back on Earth. If your journey is too long, you might be gone for 10 years and everyone else on Earth ages 100. So you've effectively gone into the future, and then everyone you knew when you left Earth is now dead, right? So there's a cost to going into the future in that way. If you want to go into the past, that's a little more problematical. Because if you go into the past and find a way to prevent your parents from meeting, then you would have never been born to then go into the past to prevent your parents from meeting. Her head is exploding now, I think. No. So there are some suggestions about how to go into the past, but you go on a trajectory, a space-time trajectory that does not intersect back with yourself. So you can't really interfere with your own past. And so that requires huge energy to execute. And we're still pulling oil out of the ground, so there's no energy anywhere close to acquiring. So the simplest way is to go forward in time by traveling very fast. How fast? A lot faster than any piece of hardware we've ever made. So the answer is no right now. It's not technologically realistic to time travel. So that's reserved for science fiction at this point, such as Doctor Who's TARDIS or anything else, okay? Whoa, is it what, was that the two, or is that the one? How about one? Who's got the best question here? We'll go. Who's got, we got what? She's about ready to bust the gasket here. Okay, so ma'am, this is the last question of the evening. So I don't want to put pressure on you or anything, but this will be how this evening is remembered, okay? Okay, go.
Will you sign my undergraduate astronomy textbook?
Oh, that's not good! I have a quick answer for that, but I want to take another question for that. But wait. My quick answer is, I'd be happy to, but I will not have time. So on my website is my address. Just mail me the book. I'd be happy to sign it and send it back to you. Okay? I do that all the time, and it's fine. Okay? Who's got an awesomest question? What? We got 12 hands pointing in. Sir.
So I'm thinking about science as a career, and up until this day, I'd always thought research. Research is what science is. But when I see you, it seems like a lot of science is telling people about research. So what should the relationship be between doing the work and making people understand it?
I will end on that question. So, my energy for communicating science derives from the research that I do. The research, for me, is thrilling. The press reports the results of research, which for some projects can take many, many years. So if you want to become a scientist, you have to learn to love the questions just as much as the answer, because in fact, in some cases, you don't even get to an answer. You find out you're navigating the wrong path. So the people who say, "Oh, a graduate school is I can't," that is science. What you're doing as a graduate student is becoming a research scientist. And that's what you do. You work long hours. You're in the lab. You occasionally forego personal hygiene. You know, this is what that is, okay? I bet you Darwin and Newton did not smell very good, all right, is my guess, okay? Newton, while he is discovering calculus, all right, he's probably not saying, oh, I need a shower about now. No, he's pretty focused doing what he's doing, all right? And so that's where I derive my energy to share the passion. Now, I would do so no matter what. But there's a more important reason for doing it. And that is most pure research in the sciences that goes on in America today, that's not product driven, goes on at universities, and the source of those monies are from public-based, tax-based funding agencies. So, collectively, we pay taxes to the country's portfolio of spending, some of which funds the science that's conducted by scientists. As a result, the science that's done, the scientist that conducts the research, is obligated to the public to share with them the fruits of their research. The public paid for it. And I submit to you that there was an era before that was taken seriously. There was an era where the scientist in the lab would say, the press is beneath me, they'll probably get my story wrong, I don't want to have anything to do with them, leave me alone. That happened only to the peril of the funding stream that went into those labs. And the first person to realize this in a big way was, in fact, Carl Sagan. Because what happened was, he would start bringing science to the public. He did it sort of first and best. And colleagues said, what, you're on the Tonight Show? You're a scientist, and you'd stoop to go on the Tonight? And he was criticized for this. Criticized. Meanwhile, the scientific community saw their budgets rise. And so in astrophysics, we learned earlier than in other fields the value, the general value of bringing the fruits of our research to the public. And I can tell you that I don't know if I'm biased, probably I am, but maybe a little bit is not. I think Hubble images are pretty cool. I think these pictures I showed you tonight are kind of awesome. I think all of us, at some point, we look up and wonder what our place is in this universe. And a small fraction of the total population gets to actually call that their career. So at no time do I take it for granted that it is not only a privilege to study the universe, it's an honor to do so with the sanction of those who are taxpayers and who even come out and hear a lecture that I give. Thank you all again. Seattle.